Hello all. Welcome to the series of solid principles. In the last video, we learnt about Liskov substitution principle at a higher level. In this video, we will dig into this principle more deeper. So, let's get started with an example. Let's say we have a generic car class. And then, we have an electric car that extends this generic car class. Let's see how the code of this simple inheritance looks like. The car class has one method getEngineCapacity that returns the volume capacity of the engine present in the car. Now, electric cars do not have conventional engines and they run on rechargeable batteries. Therefore, the electric car class overrides the getEngineCapacity method and leaves it unimplemented. Now, let's create some objects of cars and electric cars. Let's instantiate 3 objects with reference type car. Note that, even though the reference for all 3 objects is car, 2 of them are generic car instances, while the third one is an electric car instance. We insert all 3 car reference objects into an array list, and we iterate through the car list, and we print out the engine capacity of each car. The first 2 iterations of the loop will work fine and print the engine capacity of generic car. However, in the third iteration, the object is an electric car object, and the getEngineCapacity method in electric car is unimplemented. So in the third iteration, this code will not work correctly because of an unimplemented method. This is a design hole that needs to be corrected. So how do we fix this? One of the solutions is to break the inheritance. Let's see how it can be done. We will create a class called vehicle, which has one method called getVehicleCapacity. Note that it is neither engine capacity nor battery capacity, but a much more generic abstraction called vehicle capacity. Now, we have the car class and electric car that extends vehicle. The car class overrides the getVehicleCapacity method internally, and the electric car class also overrides the same getVehicleCapacity method, which in turn calls its getBatteryCapacity method internally. So, that is the code restructuring that is needed to follow the new hierarchy. Let's run the same piece of main method code. Again, we have the first 2 car objects and the third electric car object. Note that all 3 are of reference type vehicle. In first 2 iterations, the getVehicleCapacity method gets called on the car objects. The car objects, in turn, call their getEngineCapacity method. In the third iteration, the getVehicleCapacity method gets called on the electric car objects, which in turn, call its getBatteryCapacity method. So, the code worked correctly now by breaking the hierarchy in existing design. This is the first example for applying the Liskov Substitution Principle. In the next video, we will apply another kind of solution pattern to ensure that our design follows Liskov Substitution Principle. Thank you for watching. Please subscribe for more such content.